Hi everyone, this is Revathi M, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. SNS Rajalakshmi College of Arts and Science. In this series, we discussed about the theoretical fundamentals of artificial intelligence. Today, we are going to see about efficiency consideration for Prolog programs. So, efficiency consideration for Prolog programs in the classroom, we focus on how to write programs that not only produce correct results but also execute quickly and use resource effectively. In Prolog, efficiency depends on how the rules and facts are ordered, how recursion is structured, and how to search space is controlled. For example, placing more specific class before general ones can reduce unnecessary backtracking. Similarly, using cut appropriately can prevent Prolog from exploring redundant alternatives, improving performance. However, cuts must be used carefully to avoid changing the logic of the program. Another important aspect is using tail recursion. So instead of tail general recursion, whenever possible, a tail recursive programs reuse stack space and execute faster. Efficient data representation like using lists and built-in predicates wisely. First, we see the how to avoid redundant computations. So when teaching the concept of avoid redundant computations in Prolog, you can explain that it refers to preventing the program from performing the same calculation or logical checks multiple times unnecessarily. In program redundant computations often occur because of repeated goals or inefficient rule definition that cause the interpreter to re-evaluate the same subjects during backtracking. To avoid this, programmer can store intermediate result using techniques like memorization or by recording rules so that frequently used results are computed only once. For example, instead of calculating the same predicative several times with different class, it's better to compute once and reuse the result. Additionally, we're using a use of cuts. So this operator to prevent unnecessary backtracking. By reducing redundant computation, we improve the program speed, efficiency and clarity, ensuring the Prolog logical search process is more focused and effective. Next, we see the ordering of classes. So when explaining ordering of classes in Prolog to students, you can highlight that the sequence in which class are written in a program greatly affected efficiency and behavior. Prolog follows top to bottom search. Bottom search strategy, meaning it always try to satisfy goals using the first matching clues it find. Therefore, placing more specific and frequently used class at the top and can save time by reducing unnecessary backtracking. For instance, if a rule that succeeds quickly is placed before 1-2 tasks longer or fail often, Prolog can reach the correct answer faster. On the other hand, if the order is poor, the Prolog may waste time exploring irrelevant or failing classes. So careful classes ordering not only improve execution speed but also makes the program easier to read and debug. Next, we see the use of efficient data structure. We know in data structure, we consider binary tree or structure instead of list. So when discussing use of efficient data structure in Prologs, it's important to explain that the way data is represented can significantly affect the performance and clarity of the program. Prolog provides several data structures such as list, trees, and compound terms, and choosing the right one help reduce computation time and memory usage. For example, lists are simple and flexible but may be inefficient for frequent insertion or lookup in the middle. In such case, different lists can improve performance. So it avoids the traversing long list, consider indexes or databases. Next, we see the use of tail recursion. Tail recursion is one of the main for efficiency in this topic. So tail recursion optimization in Prolog, you can tell students the tail recursive calls are special kind of recursion where the recursive call is the last operation in a predicate. This allows the Prolog interpreter to use the current stack frame instead of creating a new one for each call, which significantly saves memory and improves. So here one example, sum underscore list with accumulator avoids multiple stack frames. Next, we see the profiling and optimization tools. When teaching profiling and optimization tools in Prolog, it's important to emphasize that writing efficient code is not just about theory. It also involves measuring performance and identifying bottlenecks. Profiling tools also programmed to see how much time each predicate does. So for example, many Prolog environments provide built-in trackers and profilers that let you monitor the execution of programs step by step. Using these tools, students can detect inefficient recursion, redundant computations, or poorly ordered classes. Next one is the built-in predicates. So here we prefer the built-in predicates. So member by 2, append by 3, find all. They are optimized compared to custom code. So already we seen in the last class what is predicate logic, what is the subject, and what are the predicates we are using, what are the methods we are using in predicates. So at final, the mind map of this efficiency consideration for Prolog programs. First, we have to avoid redundant computations, ordering class, use of efficient data structure, use of tail recursion, profiling and optimization tool, use of built-in predicates. So avoid redundant computations, we use the cut symbol and memorization. In use of tail recursion, we used optimization by Prolog interpreter. For example, we seen some list we are used. Avoid multiple stack frames. So these are the mind frame for the efficiency consideration for Prolog programs. I hope you enjoy this section. Thank you.